आइए हम सुने विज्ञान की अनकही कहानियाँ। आइए हम सुने विज्ञान की अनसुनी कहानियाँ। एक नई दुनिया की आवाज़ आपकी आवाज़, विज्ञान की आवाज़, की आवाज़।
We bring you all a podcast series on STEM popularization, that is, science, technology, engineering, mathematics, and medicine, supported and catalyzed by the National Council for Science and Technology Communication, the Government of India. Program is produced by Media for Community Foundation.
Hello everyone. Allow me to introduce a unique collaborative platform, the Indo French Center for the Promotion of Advanced Research, popularly known as CEFIPRA today. It's all about fostering partnerships between India and French scientists, encouraging collaboration across a wide range of scientific fields. Now, let's understand more from a scientist.
My name is Sriram Ramaswamy. I am a professor of physics here at IISc. I've had two major CEFIPRA projects. The more recent one ended in around 2010, and in an earlier phase, actually in the 1990s, also one of the earliest CEFIPRA projects. Both of them, I think, were very successful. We were very happy in dealing with CEFIPRA during that process. I'll talk mainly about the second one. What had happened was that both the Paris group and us had been very interested in the collective behavior of living matter. Collections of organisms moving together, or inside one cell, little molecular motors and filaments moving together. So we decided it would be natural to write a joint project. So we called the project the Mechanics of Living Matter, which you can see if you see the screen behind me. I don't know if you can see it, but Mechanics of Living Matter is La mécanique de la matière vivante is what we called it in French. And it was actually a fairly large number of people on both sides. On the French side, it was Jean-François, Jacques Pro, David Lacoste, and on our side, it was four of us, Gautam Menon, Madan Rao, Yashodhan Halparne, and myself. The project had many very nice outcomes. If you look at the single most sort of major outcome, really I think is that collaboration established the language, the rules of the game, and the framework for understanding the mechanics of living matter. It resulted in what has become a very famous, let me find that paper, a very famous review article, including several people from the collaboration and some not from the collaboration also. I'll just show you. Hydrodynamics of soft active matter. It came out some years after the project ended, but in fact, the initial meeting that took place, the result of which we wrote this, was in Paris in maybe 2007. We started deciding to do it during a CEFIPRA visit of mine. And Jacques Pro, Madan Rao, and Jean-François Joanny, and myself were the four CEFIPRA collaboration members in this project. And this article is I would frankly say, quite famous. It has defined the field, and it is still the article that people refer to, where we sort of set out, what is this subject about? How should you think about it? What are the achievements so far? What is happening in the future? So that's one big thing that happened as a result of this. And I would say the existence of this, what I may immodestly call a sort of famous review article, is very much thanks to the CEFIPRA collaboration. There were other people on the project who were not CEFIPRA, whom also we happened to encounter during the Paris visit. Apart from that, there were many other collaborative pieces of work. In those early days, although I was not on that paper, Ranjit, who is now a professor at IIT Bombay, was a postdoc on the project, hired again on CEFIPRA funds, hired in Paris. And Ranjit has gone on to do very well indeed. In fact, this year he became a fellow of the Indian Academy of Sciences. He's one of India's best biological physicists, and he's made a sort of very substantial transition really to working in the biology domain, because in IIT Bombay, he is not in the physics department, he's in the biosciences and bioengineering department, and he's doing very well. An early other facility that Cefipra afforded us was to send one of our students to Paris. So Ananya Maitro, a student, spent a couple of months in these early days of the project at Institut Curie. This is all old data, this is back in 2010, but Ananya was experienced there, went on to his doing very, very good work. In fact, now he is a CNRS faculty member in Paris. Then Gatien Verlet was a student at ESPCI who spent a few weeks here at IISc and at Raman Institute and at IMSc. I don't remember what he's doing currently. Specific collaborative papers included joint work by Lacoste, Gautam Menon and Joanny, as well as a rather nice little collaboration between Jean-François Joanny and me on the spreading of active drops. These were all nice little papers. Probably the sort of big outcome, the defining outcome, was this big review article which I already talked to you about a little while ago. The other benefit of the collaboration wasn't always in the form of papers co-authored by French group and us, but discussions that took place in both directions. So even a lot of the work on both sides that wasn't directly collaborative between the two groups involved acknowledgements to helpful discussions with the other group, and there were several such papers that came out. For example, there was this nice paper with one of my postdocs in those days, which in fact eventually led directly to the collaborative work with Joanny. So I would say the field as a whole, and not only our research, advanced very well thanks to this project. Okay, I can give you an example of one kind of little scientific problem that Jean-François Joanny and I worked on, which was supported by the project. It's a kind of simple question. You know, if you take a drop of water and put it on a surface, then depending on the surface, it will spread or it will not spread. Right? Some surfaces get wetted by some liquids, some surfaces, like if they don't get wetted. If the surface is specially treated, then the drop of water sits and forms a bead. Also, it depends on the liquid. You know, the mercury on many surfaces just stays almost like a bead, it doesn't spread out. Water on many surfaces spreads. So our question was, supposing the drop itself contains active objects. Active objects mean objects like organisms that are swimming and pushing the fluid, or little machines that are creating internal flows in the fluid. How do the laws governing spreading of a drop on a surface change when that happens? So Jean-François and I worried about this question. Aspects of it had earlier been studied with a postdoc in the course of the project. She was actually hired by an institute postdoc position, but that work was very much informed by discussions with Jacques Pro. So JF and Jean-François and I studied this problem, and we found it was a completely new regime where the laws governing how fast the drop spreads when there's active processes going on inside was very different from what you got in the case of an ordinary equilibrium liquid drop. So we found new laws, new equations and new laws governing the spreading of this drop. And we thought that was rather fun. That is one, as I said, not the most profound outcome, but it's a nice case of a novel direction being defined and new emergent physical laws coming out. So that's all.
This episode is brought to you with the content support from Cefipra and the technical support from the Sparrows team. We extend our heartfelt thanks to the Director of Cefipra, Professor Nitin Seth and Dr. Payal for their continuous guidance and support. Stay tuned for more episodes and thank you for joining.
आइए हम सुने विज्ञान की अनकही कहानियाँ। आइए हम सुने विज्ञान की अनसुनी